Now I am going to discuss with you about the kinematics of circular and rotational motion. So what are the circular and rotational motion? If if some particular body is moving along a circle, then motion is called the circular motion. And if a body is rotating about about an axis, suppose somebody is rotating about y-axis, then the motion is known as rotational motion. There are some variables which are required to study the kinematics of circular and rotational motion, and those are: first, angular displacement. Theta. So theta is defined as the arc by radius, and it is a dimensionless quantity. And its SI unit is radian. While its practical unit is degree or revolution. So 1 revolution means 2 pi radian. So this is circular motion, this is rotational motion. Angular displacement theta behaves as an axial vector when it is small. In that case, d theta 1 plus d theta 2 is equal to d theta 2 plus d theta 1. But it is not a vector when it is large. That is, theta 1 plus theta 2 is not equal to theta 2 plus theta 1. That is, when displacement is small, commutative rule is followed, and when it becomes large, commutative rule is not followed. In case of angular displacement, when a body makes n revolution, then angular displacement becomes theta is equal to 2 pi into number of revolution, that is 2 pi n. Angular displacement of all points of a rigid body is same. In this case, this is a rigid body and you can see the angular displacement of particle at, at each point remains same. But in case of non-rigid body like chain, angular displacement of the body is greater at the greater distance from axis of rotation. So in case of non-rigid body, this theta 2 is greater than theta 1, but in case of rigid body it remains same. Second variable is angular velocity. The angular velocity is nothing but the time rate of change of the angular displacement, and it is denoted by omega, and it is a physical quantity with dimension t minus 1 and its SI unit is radian per second. It is an axial vector. The average angular velocity can be written as theta 2 minus theta 1 divided by 2 minus t1, where theta 1 and theta 2 are the angular displacement at different times t1 and t2 respectively. And in case of instantaneous angular velocity, this angular displacement may be defined as omega is equal to limit delta t tends to 0 delta theta by delta t, that becomes equal to d theta by dt. And in case of uniform circular or rotatory motion, this omega average is equal to instantaneous angular velocity. Therefore, we see that in case of a rigid body, all points rotate with the same displacement and with the same angle and in same time, that is angular velocity remains same for all points on the rigid bodies. Therefore, angular velocity is a characteristic of the body as a whole. For example, in case of all points on earth, the angular velocity is same, that is equal to 2 pi by 24 radian per hour. Now, if a body makes in rotations in t second, then first angular displacement theta will be 2 pi n in time t. Therefore, average angular velocity will be given by total displacement 2 pi n divided by the total time taken t radian per second. If suppose t is the time period and f is the frequency of uniform circular or rotational motion, then in that case t will be given as t by n and t is equal to 1 by f. Therefore, omega will be equal to 2 pi by t is equal to 2 pi f. This is the important relationship. With the help of this, we can solve many physical problems. Further, angular velocity depends on the point about which rotation is considered. For example, if a particle is moving on a circle from P to P prime in time t, then the angular velocity with respect to O will be omega is equal to beta by t, where beta is the angular displacement. And with respect to A, the angular velocity omega A is equal to alpha by t, where alpha is the displacement regarding the rotation about point O. But from geometry, beta is equal to 2 alpha. So we get omega about O is equal to 2 omega about A. Therefore, there is a relationship between the two angular velocity. Further, if two particles are moving on a same circle or different coplanar concentric circles in same direction with different uniform angular speed omega A and omega B, respectively, then the angular velocity of B relative to A for an observer at the center will be omega B minus omega A. So the time taken by one to complete one revolution around O with respect to the other can be given as t is equal to 2 pi by omega relative is equal to 2 pi by omega 2 minus omega 1. And by using the relationship for omega and time period, we can calculate t is equal to t1 t2 divided by t1 minus t2. Further, if the omega b is equal to omega a, then the relative angular velocity will be 0, and in that case the time period will be equal to infinite. That means further, if the omega b is equal to omega a, then the relative angular velocity will be 0, and in that case the time period will be equal to infinite. That means particles will maintain their position relative to each others. This is what actually happens in case of geostationary satellite. Or in case of rotation of a rigid body. Now let us consider two particles are moving on two different concentric circles. Particle A is moving with radius RA and particle B is moving on a circle with radius RB. Then the angular velocity of B relative to A as observed by A will depend on their relative velocity as well as their relative position. That can be written as omega relative is equal to V relative divided by R relative, and that can be calculated with relationship V2 minus V1 is equal to omega 2 minus omega 1 cross R2 minus R1. Now the third variable is angular acceleration. Angular acceleration of a body is defined as the time rate of change of the angular velocity. That means angular acceleration can be given by change in angular velocity with respect to the time, that is equal to delta omega by delta t. Angular acceleration works only when the angular speed of the body is not constant. The instantaneous angular acceleration can be written as limit delta t tends to 0 delta omega by delta t, that gives d omega by dt. Angular acceleration is an axial vector and it has dimension t minus 2 and its unit is radian per second square. Regarding the angular acceleration, it is worth to note that if angular acceleration is 0, then circular or rotational motion is said to be uniform. Therefore, if any motion is uniform, then in that case acceleration is 0, and since omega angular velocity is the time rate of change of the angular displacement, therefore angular acceleration can be written as d omega by dt is equal to d by dt of d theta by dt is equal to d2 theta by dt square. That is, angular acceleration is the second time derivative of the angular displacement. If a torque acts on a body of moment of inertia I, then there is a relationship between torque and inertia I given by torque is equal to I into alpha, where alpha is the angular acceleration, and this is analogous to F is equal to m into a. Angular acceleration is same for all points of a rigid body. Friends, this is for now. If you enjoyed this video, please like, share with your friends, and if you are watching this channel for the first time, subscribe the channel and press the bell icon. Thank you.